Assalamualaikum and salam sejahtera. In this lecture, we are going to discuss about two types of asymptote, which are vertical asymptote and horizontal asymptote. Firstly, we look to the vertical asymptote. From the given graph, here, the vertical dotted line, which is at x equal to a, is called a vertical asymptote. The function f has a vertical asymptote at x equal to a because when x approaches the value of a, fx gets large or low without limit and never quite touching it. Now we look to the definition of vertical asymptote. A line x equal to a is a vertical asymptote of the graph of the function y is equal to fx if either limit fx when x approaches to a from left is equal to the infinity or negative infinity, or limit of fx when x approaches to a from right is equal to infinity or negative infinity. Now we look to the example 1. Find the vertical asymptote of fx equal to 1 over x squared. To find the vertical asymptote, we take x squared is equal to 0, so x is equal to 0. So we can say that the vertical asymptote is x equal to 0. Now we look to the example 2. Determine the vertical asymptote of a fx equal to x plus 3 over x plus 2. So the solution is for the fx equal to x plus 3 over x plus 2. To find the vertical asymptote, we take x plus 2 is equal to 0, so x is equal to negative 2. Since the limit of fx when x approaches to negative 2 from left is equal to negative infinity, and the limit of fx when x approaches to negative 2 from right is equal to infinity. Hence, x is equal to negative 2 is vertical asymptote of fx. Now we look to the example 2, part B. Determine the vertical asymptote of fx is equal to 1 over x squared minus 1. So we take the x squared minus 1 is equal to 0. So x minus 1 times x plus 1 is equal to 0. So x is equal to 1 or x equal to negative 1. Since limit of fx when x approaches to 1 from left is equal to negative infinity, and limit of fx when x approaches to 1 from right is equal to infinity, and also the limit of fx when x approaches to negative 1 from left is equal to infinity, and the limit of fx when x approaches to negative 1 from right is equal to negative infinity. Hence, x is equal to 1 and x is equal to negative 1 are the vertical asymptote. Now we look to the example to part C. Given that fx is equal to 2x over x squared minus x minus 2, by taking x squared minus x minus 2 is equal to 0, so we have x minus 2 times the x plus 1 is equal to 0. So we have x is equal to 2 and x is equal to negative 1 are the vertical asymptote, since the limit of fx when x approaches to 2 from right is equal to positive infinity, and limit of fx when x approaches to 2 from left is equal to negative infinity, and the limit of fx when x approaches to negative 1 from right is equal to positive infinity, and the limit of fx when x approaches to negative 1 from left is equal to negative infinity. Hence, x equal to 2 and x equal to negative 1 are the vertical asymptote. Now we look to the horizontal asymptote. A line y is equal to b is a horizontal asymptote of the graph of function y is equal to fx. If either limit of fx when x approaches to infinity is equal to b, or the limit of fx when x approaches to negative infinity is equal to b. For example, from the graph above, as x approaches to infinity, gx approaches but never reaches the value of 0. By using the limit notation, we state that limit of gx when x approaches to infinity is equal to 0. Hence, gx has a horizontal asymptote of y is equal to 0. Now we look to the example 3. From the graph above, we can see that if x approaches to negative infinity, fx approaches but never reaches the value of 4. By using the limit notation, we state that limit of fx when x approaches to negative infinity is equal to 4. And fx has a horizontal asymptote of y is equal to 4.